Alrighty, hello everyone, this is Kevin. Uh, this is number 3 from homework 9. Sorry about being late, I had an exam yesterday that was preparing for. So either way, for A, we're being asked what's the speed when it leaves the roof. So, if you remember, uh, the only energy this thing gains is the change in potential energy, which comes from the change in height. More specifically, it's a mgh, or delta H. That's the only way it gets energy from. And it's split into kinetic energy, just like before. However, this time it has two kinds of kinetic energy, like regular kinetic energy and rotational energy. So the change in potential energy, mgh, equals your ke plus your, I'm going to call it rotational energy, or 1/2 mv squared plus 1/2 in moment of inertia, I think, w squared. So we want our terms in w, angular speed. So we need to sub out all of these variables that either we don't know or don't want. So for m and g, we can already sub those out. But we can also sub out h, which is the change of height. So let's find delta H. If you notice, delta H right here is the opposite of this theta, so it would be sine of L. And then the sine, in my case, the angle is 25, so you take L, which in my case is 5.7, times it by sine theta, in my case 25, and then that gives you your delta H. So then here I plugged in my mass, my gravity, my delta H's, mass again. So now I'm stuck with a v squared and a moment of inertia and angular velocity. I think that is squared. So we want everything to be an angular velocity because we want to make this have only one variable so we can solve this. So we need to somehow rewrite velocity in I. Velocity, if you remember, is just radius times angular velocity. And we know radius. And then I, well, the moment of inertia for a solid cylinder is just 1/2 mr squared. We know m, we know r. So then we can plug in velocity as radius times w, and we can plug in I as 1/2 mr squared, and then plug in your radius and your mass, which is given in the question. Make sure your radius is in meters. And then you should be left with just angular momentum, which you can just simplify. There's a lot of ways you can do this. Right here I just added them together, divided both sides by the coefficient, and then square rooted it. At that point it's more math than physics. So B. Let's see. They're asking us about how far it falls off. So this is just a projectile motion problem, but slightly different. So for any projectile motion problem, we need to know how fast it's going in both directions, the y and the x. So velocity, if you remember, is just radius times angular velocity. So we need to turn our angular velocity into regular velocity first. So that's why you take your answer from A, multiply by your radius, and you get your velocity. This is the total velocity it's falling off. So right here, this red line would be 5.6 whatever from here. But if you remember, you should always break it up into the x and y components. Always, always, always do that. It makes it so much easier, if you can. So for the x component, in my case, it's 5.61 times by cosine theta, because the x is adjacent to this theta right here, which gives you a number. And then the y component is just opposite, which is sine. So now we have the x and y components that the ball already has before it starts falling. So in order to know distance, we need velocity over time. We have velocity in the x component now, so now we need to find time. We know the distance that the ball is going to fall vertically. It's given. In my case, it's 5.9. You should find it here. And I can set this to v naught time plus 1/2 at squared. This is just from the first unit, I think. So v naught is our y speed. Only our y speed, because we're only concerned at our y right now. We already did our x. So then you set d to be negative because it's going down. At least that's how I define it, because I define gravity as down. However you do it, it's fine. And then the velocity is negative because it's going down as well, plus, well, 1/2 at squared, which is just 1/2 of gravity. And then you need to solve this equation. You can use a lot of different ways to do this. I use quadratic formula. Yes, it does give you imaginary numbers, but that's because of slight rounding errors. Imaginary numbers can just be ignored. But however you solve this, then you should get a time. And then you find the amount of seconds it takes to fall. So now that I know the speed in the x direction, I found that before, I know how long it takes for it to hit the ground. So we can find the distance simply just using d equals v naught t. And then that gives us your answer.